Here's page 3, number 8. Sorry, I cut off on that previous one there, but it asks, given this graph of f of x, that you are to sketch, it says omitting points where f of x is differentiable. I'll show you how that works. But you're supposed to take the graph of f given and graph f prime of x, and let me show you kind of how that works. It's a great exercise in just recognizing slopes. So if you take and you plot the slope values, so what I just did right there is I put a 0 on that line, because the slope of that little section is 0. And then over here, this little section has got a slope of up 1/2, so that'd be a slope of half. And then, again, I just highlighted those. The other, like more curvy parabolic looking graph, all I did is mark 3 little places where I think I know the slope. Like the positive slope, there is, looks like kind of like 1, a slope of 1 to me. The top of the peak, it's 0. And on the downhill part there, I think it's -1 is the slope. So I'm going to take all those and plot just those values down below, because the graph of f prime, remember, is just plotting the slope values that you see. So if I'm going to plot the slope values of that orange section with the slope of 0, I need to, from 0 to 3, have a line at a height of 0, because its slopes during that stretch of f of x are 0. And then I do a horizontal line at a half, because for that entire section from 3 to 5 in my f of x function, the slopes are all 1/2. They're always 1/2 in that section, so it's constantly at the slope or the slant of 1/2. So you have a flat line for your derivative. And then for the green part, I just plotted little points where right below those little tangent lines that I drew, where a slope of 1, I think it occurs like right before 6, 5.9-ish, something like that. And then at the top of the peak at 7, that slope is 0, so I plotted a point at 0. And then at the downhill slope after 8, somewhere in there, the slope was -1, and I haven't plotted that one. It looks like I put one at the wrong place. Sorry about that. There it is. Looks like I put it at a positive 1, doesn't it? So there's -1. Okay, so there's that. And let me erase that little silly thing right there. But that would be a slope of -1, so I plotted a point. If you look at those and you just kind of infer in between there, they go from positive to 0 to negative, and if you filled in more slopes in between there, it'd make a nice little line in between. Whoops, I'm using the wrong thing. Undo that. So you've got a line that goes like this. That's the slope. And if you keep going, I think the section, this would all just be a line like that. The slopes go from positive, and they get less positive toward you get till 7. X equals 7, they're at 0. And after x equals 7, the slopes on f of x get negative, so you see the derivative graph goes below. The only other thing to add to this is that at the corners, at the f of x function, remember corners and cusps, the slope is undefined at corners and cusps. So down here, the derivative is undefined, has no value at any location at those corners and cusps. So I'm putting little circles there. Those are holes, because at x equals 3 and x equals 5, you can't do a slope at a corner or a cusp, and those are corners. So that's the end of it. So hopefully that helps a little bit, and I'll send the next pages pretty soon.